Hey there, and welcome to this explainer. So, have you ever been stuck in a store, staring at a shelf, trying to figure out if a bulk deal is actually a good deal? Or maybe you found yourself kind of freezing up when trying to scale a recipe up for a huge party? Well, today we're unlocking a mental math superpower that will completely change how you tackle everyday logic puzzles. Get ready, because we're going to break down a wildly effective problem-solving framework.
Picture this. You're standing in the stationery aisle. You see a pack of 5 pens for 100 rupees. But you don't need 5. You need exactly 8 pens for your office team. So how much is that going to cost you? Let your brain struggle with that for just a second. Trying to jump straight from 5 to 8 is, honestly, it's pretty clunky, right? If you're drawing a blank, do not worry, because you're about to learn the absolute secret weapon for problems exactly like this.
Okay, let's dive right into this. This secret weapon is called the unitary method, and it's all built around this rule of 2 philosophy. You see, instead of trying to leap directly from 5 pens to 8 pens, which, let's be real, just makes our brains hurt, we solve the problem by first finding the value of a single solitary unit. Just one item. The word unitary literally comes from the word unit. The whole trick, the whole shebang, is to get down to one first and then scale up to whatever number you actually need.
It really all boils down to a simple rhythmic anchor. Say it with me in your head. Many to one, one to many. Step 1, you find the value of 1 unit. And to do that, you're typically going to divide. Step 2, you find the value of the many units you actually want. And for that, you multiply. It's a foolproof stepping stone kind of approach.
And this brilliantly illustrates the methodology in action. We start right at the top with our known fact. 5 pens cost 100 rupees. Now, to get down to our single unit, just one single pen, we do step 1. We divide that 100 by 5. That instantly gives us 20 rupees for 1 pen. That right there is our absolutely crucial many-to-one step in action.
Now, once we know that 1 pen costs 20 rupees, finding the cost of 8 pens, or 80 pens for that matter, is incredibly simple. We just scale back up. If you visualize each of those 8 pens as a 20 rupee block, we simply calculate 8 times 20, which of course equals 160 rupees. That is the one-to-many step. You literally just multiply that single unit value by what you need, and boom, you've got your answer.
Let's test this mental framework out in the real world. Say you're filling up your car. If 4 liters of petrol costs 360 rupees, what do 7 liters cost? Try to run those 2 steps in your head right now. Go on, I'll give you a second. Boom, 630 rupees. Now, how did we get there so fast? Many to one. 360 divided by 4 gives us 90 rupees for a single liter. One to many, 90 rupees times our target of 7 liters equals 630. It's fast, it's highly logical, and once you get the hang of it, I promise you it works every single time. All right, let's keep the momentum high. Here's another scenario, but this time we're dealing with speed instead of money. Imagine you're rushing to finish an essay. You know you can type 300 words in 5 minutes. So, how many words can you bang out in 12 minutes? The answer is 720 words. Again, we're just applying the rule. 300 words divided by 5 minutes means you're typing at a pretty solid rate of 60 words in exactly 1 minute. Multiply that 1-minute rate of 60 by the 12 minutes we're actually looking for, and you get 720 words. Easy, right? So the crucial point here is that everything we've done up to now falls under what we call direct proportion. That basically means when one amount goes up, the other goes up too. More pens cost more money. More minutes mean more words typed. But what happens when the logic flips entirely on its head? Well, welcome to the inverse twist. In inverse proportion, when one amount goes up, the other amount actually goes down. Now, what's really interesting when we look at these side by side is that the difference is just visually striking. On the left, we see the direct proportion we just mastered. You know, that green line rising steadily. More pens equals more cost. Simple. But take a look at the red graph on the right. It's a falling curve. As the number of workers increases, the days needed to finish a job decreases. One goes up, the other goes down. Let's actually see this inverse twist in action with a classic example. Read this problem with me. If 4 workers build a wall in 12 days, how long would it take for 6 workers? I'm actually going to pause here and let the counterintuitive nature of this puzzle sink in for a second. Your first instinct might be to just divide first, like we did before. But hold on. If you have more workers on the job, it should take fewer days, right? Exactly. The correct answer is 8 days. Here's the trick for these inverse problems. To find the work of one single unit, meaning one worker, you actually have to multiply first. Think about it. One worker working entirely alone is going to be way slower, so it would take them 4 times 12, or 48 days to build that entire wall by themselves. Now that we have our total workload of 48 days for a single person, we then divide that 48 by our new, larger team of 6 workers. And 48 divided by 6 gives us 8 days. It perfectly matches our real-world logic. More workers, fewer days.
And there you have it. You've successfully conquered both direct and inverse proportions using a super simple 2-step logical flow. So I want to end with a provocative thought. How are you going to use the unitary method logic on your next trip to the grocery store? Seriously, the next time you see one of those confusing bulk discounts or a tricky 3 for $50 sticker, I bet you'll be automatically finding the value of 1 before you even reach the checkout line. Thank you so much for joining me for this explainer, and keep those problem-solving gears turning.